It's just actually something different.
Okay, so today we're going to be learning about graphs of basic rational function. Cole, what is a basic rational function? How do we differentiate a basic and a non-basic rational function? Today we're going to be focusing on the basic ones, but tomorrow we're going to be talking about non-basic. So what's the difference between a basic rational function to a non-basic? All right, so we will know if a function is a basic function if the numerator is constant, right? Just like, for example, if you have 1 over x plus 2, the numerator is 1 and it's a constant number. And so 1 over x plus 2 is a basic one, right? A basic rational. But if the numerator has a variable, let's say x plus 5 over x minus 2, then that rational function is a non-basic. So we're going to be talking about the features of that graph, of that non-basic tomorrow. But again, today we're just going to be focusing on basic, right? Again, by definition, a rational function is built by dividing two polynomial functions because there are a wide variety of different types of rational functions. The lesson today will just be focusing on this, okay, where the numerator is constant. So 1 over x, this one is considered as basic rational, right? Because again, this is the numerator of this function is just 1 and it's constant, right? And this is our parent basic rational function, okay? Now, remember also on the quiz, we had to identify or determine the excluded value, right? So if this is our function, what is the excluded value? 0, right? So EV, excluded value, x can't equal 0. Okay, because if the denominator is 0, the function will be undefined. Okay? All right, so we should know that because in the graphing part, this is going to be our basis for the asymptotes. Okay? Because again, these are the excluded values. The graph should be undefined at this value, right? Okay, so if x is -2, what is your f of x? If you plug in -2 to the function 1 over x, -1/2, right? Or you say 1 over -2, or I can just write that as -1/2. If x is -1, if you plug it into the function, what is your y? 1 divided by -1 is -1. Yes? If x is 0, is undefined. Okay. Okay? So that means if x is 0, the y value, I'm just going to write y is undefined. Okay, so the undefined part will also give us the asymptote. Okay, and then if x is 1, okay, what is the value? If x is 1, that's going to be just 1 over 1. If x is 2, that's 1/2. Okay. Again, since we cannot allow x to be 0, this x equals 0 is going to be your asymptote, one of your asymptotes. Okay, so that's going to be a vertical asymptote. Okay, x equals 0 is your VA, right? And we know it's a vertical asymptote. And then since y cannot be, if x is 0, y is undefined, therefore, this is also another asymptote. Okay? This is our horizontal asymptote, or HA. Okay? Makes sense? So we have two asymptotes for rational function. In exponential, we only have one. In polynomial, we don't have an asymptote, right?
I don't understand why we can't have y equals 0.
Because if x is 0, the function would be undefined. So also the y.
It's a horizontal asymptote and y equals 0.
Horizontal asymptote, y equals 0. I'm just writing the line, the equation of the line. So this line has this equation, right? But we're writing that to draw the line. But we know that it can't equal 0.
So you're saying something like that.
Yeah. Again, once we write the equation of the line, it should be x or y equals something, right? Okay. All right, so let's plot the points here. We got -2, -1/2. Where's that? When x is -2, y is -1/2. That's right in here. -1, -1 should be right there. And then if x is 1, y is 1. And then if x is 2, y is 1/2. Now remember, the asymptote will just be our
Excluded value.
excluded value. And it's also, from the graph, that's also going to be
Horizontal asymptote.
our guide, or what? Yeah, an asymptote can be horizontal or vertical, but that's our guide. That's our, what do you call that? That's our, if you're going to draw the graph, okay, it's not going to go beyond these lines, right? Okay, so that means if you're going to draw the graph, you connect the points, but make sure it's not going to pass through or go beyond these lines, because these are your asymptotes, right? And same thing with the other side. Just connect the points, and then it's not going to go beyond these lines, right? So we have two parts of the graph, okay? This part and this part. Now, if we don't have a reflection, that means we're going to start at the bottom on the left side, and we're going to go to the top at the right side. But if there is a reflection, this one goes to the top at the left, and the right will go at the bottom. Make sense? Okay. We're just estimating the graph. So this is not really the accurate graph, but just to let you know the feature and how this the graph of the basic rational function looks like, right? Okay. Now, so what is the domain of this function? Yes, that's going to be all real numbers except 0, right? Yeah, so we will have two intervals, right? And we'll put a union. Remember that your vertical asymptote is x equals 0, okay? And this is our basis for the domain, right? So your domain would be all real numbers except this asymptote. So except x equals 0. Or you can say all real numbers not equal 0. You can just write that. And so if you write this in the interval notation, this is going to be -infinity to 0, union 0 to infinity. Okay? Because 0 is your excluded. And then same thing for the horizontal, right? We know the horizontal would be y equals 0. And that's going to be our basis for the range. Okay? So the range would be all real numbers except y equals 0. All real except y equals 0. So same thing, when you write this in the interval notation, we're excluding 0. So that's -infinity to 0, parentheses, union 0 to infinity. Okay? Now, what is the end behavior? If you look at the graph, where does the graph approaches to, especially for the y? It approaches to 0. So every time you have a function, and if you know the asymptotes of the rational function, the end behavior goes to the asymptote, right? Remember the features of the graph that we discussed in Unit 1? The end behavior goes to whatever's the asymptote of the graph. So I can write this as x approaches to -infinity. That means we're looking at the left side. And then x approaches to +infinity. That means we're looking at the right side. But both of these, since both of the asymptotes is 0, so both of the y's approaches to 0. Okay? I'm just going to say approaches to the asymptote, whatever the asymptote is. Okay? Any question? So basically, that's the feature of the graph of the basic rational function. And then we're going to do the transformation, and we'll have some examples, practice examples. Okay, so this is the vertex form of the basic rational function. We have the h and k here. And we always know that if we have plus h, that means the graph shifted to the left or right? Left. Okay, and then minus h, the graph shifted to the right. That's x minus h, right? I'm just going to write x plus h, this one x minus h. Okay, and then the plus k is up, and then minus k is down. And then how do we find, given the function without the graph, how do we find the vertical asymptote? We just have to look at the denominator. So we set the denominator equals 0 because that's going to be our excluded value, right, for the x. And that's going to be our basis for the equation of the vertical asymptote. So for example, if the denominator is, let's say, 1 over x plus 2, right? And so just set x plus 2 to 0. And so therefore the vertical asymptote would be -2, right, given this equation. Okay, we just look at the denominator. Now for the horizontal asymptote is based on when the graph shifted up or down, your vertical shift. So that means, given this function, it's the k value plus, let's say this is plus 5, right? Whatever the k is, right? We know this is the k value, right? And so if that's plus 5, that means the graph shifted up 5 units. And so the horizontal asymptote will also shift up 5. So we can write y equals 5. Okay, whatever the k is. Make sense? Okay. Now for the vertical stretch, that is just if your numerator is bigger than 1, right? Because if you have, let's say, 2 over x plus 2, right? The numerator is 2, right? I can write this as 2 times 1 over x plus 2. This is your parent function, right? 1 over x, then left 2. But then you multiply the 2 to the entire thing. That means the 2 there in your numerator is your stretch, okay? So this is stretch by 2. So again, if the numerator increases, if the numerator is, I can just write, if the numerator is greater than 1, then therefore you have a stretch, right? I'll just say n, numerator is greater than 1. Just write, because I don't want you to get confused with the degree. So numerator is greater than 1, there's a stretch. Now if the numerator is negative, then there is a reflection, okay? So let's say, for example, if this is -1 over x plus 2, because of the negative sign, therefore we say reflection in x, or flipped over x. Okay, so let's have these examples. And I'm going to let you do notes. I want you to do number 3. And then we'll work on 1 and 2. Okay? Okay, so the first part in your classwork is to write the description. So I'm just going to write description. Or when I say description, it's just the same as your transformation, right? So if you're asked to write the description of the function, that means you're asked to write the transformations. Okay. Now, can you give me one transformation in this function? 1 over x minus 2 plus 3. Yes, Ivy?
That it's going to the right 2.
Right 2.
Up 3.
And up 3. Okay, thank you. Right 2, up 3. All right. And then we're done with the transformation or description. Then we're going to write our domain, range, and the 2 asymptotes. Here we're not going to be doing the end behaviors yet. Okay, range, and then we're going to write vertical asymptote. I'm just going to write VA instead. Okay, you know that VA is vertical asymptote, right? So VA and then HA for the horizontal. Okay. Before we do the domain and range, we're going to fill out VA and HA first, right? So what is our vertical asymptote based on this equation? 2. You base the vertical asymptote, remember, I'm just going to write this to remember. This is your denominator. if you're going to use the function, you're going to look at the denominator of the function. So denominator is x minus 2. You set the denominator to 0, right? And that's how you solve for the vertical asymptote, by using the function itself. So x minus 2 equals 0, and so x equals 2, right? If you add 2 on both sides. So that's your VA. And then, so your vertical asymptote is your basis for the domain, because that's the set of all x values. And so, I'm just going to put an arrow. So your domain would be all real numbers except this, right? So I can write this, all real except x equals 2. So when you write this in the interval notation, that's going to be negative infinity to 2, union 2 to infinity. Okay, whatever the vertical asymptote is, right? That's your excluded. Now for the range, what is the horizontal asymptote first? What is your HA? The horizontal asymptote is based on your k value, whatever the number there after the rational expression, right? So if there's no number here, that means the k is 0. But since we have a number 3, that means y equals 3. Right? You always have to write y equals k. Okay? Since the k value is 3, therefore the horizontal asymptote is y equals 3. Okay? And then you're going to use that for your range. Okay? So your range would be all real except 3. Okay? So all real numbers except y equals 3. Okay? And so how do you write this now? That's going to be negative infinity to 3, union 3 to infinity. If you want to write the words, that's fine. But if you're asked to write the interval notation, this is how we write the interval notation, correct? Okay. Okay, now let's do number 2 together.
Do you gotta graph it?
Oh yeah, I forgot. We're going to graph this, and we're just going to estimate the graph. Okay? So what we need is just asymptotes, or are the asymptotes, right? So we know the asymptotes are x equals 2, y equals 3. So 2 is right here. And so we can draw a vertical line at x equals 2. So this is your VA, vertical asymptote x equals 2.
Why does it need to be dotted?
As long as that's your boundary line, we're just going to use dotted lines because we're not including that, right? If it's solid, that means we're including the line. And then the y equals 3, 1, 2, 3. Okay, this is going to be your HA, and that's y equals 3. Okay? Do we have a reflection in the graph? No, there's no reflection in your transformations, right? There's no negative in your numerator. And so that means if we estimate the graph, at the left side, you can try checking on your decimals. The left side, that's going to be right here, okay, at the bottom of the line, of the horizontal line. And then at the right side, should be at the top, okay? We're just estimating, so that's not the accurate graph, but that's how it looks like, okay? Any question? So we just need the asymptote. We just need to know the location of the asymptotes. Now, on your classwork, it says you do have to include an approximate graph for items 1 to 3. So that means you estimate the graph for numbers 1 to 3. Just like what I did here, okay? Any question for number 1? Okay, so let's do number 2 again. Your 3 will be your practice. Okay, and then who can give me the description for this? All the description or all the transformation?
You go left 1.
Left 1.
Down 4.
Down 4. What else? We still have 2 more. Yes, Rowan?
Would it be like times -2?
times -2. What does the negative mean? Reflection. Yes, it is reflected. And what does the 2 mean?
It's like it's a stretch.
It's stretch. Okay. So it is reflected. So we say reflection in x, or you say flipped over x, and then stretch by 2.
You forgot the one. Left one.
Oh, forgot the number. Okay. Now, who can give me the vertical asymptote and then the domain? I'm just going to write this, VA, and then HA. So what is your vertical asymptote? Anyone? What is the vertical asymptote? -1. X equals, you have to write the equation. Okay? If you just write -1, that's wrong. Okay? For the vertical, it should be x. For the horizontal, it should be y. So what is the domain? That is going to be all real except -1. So that's -infinity to -1, union -1 to infinity. Now, the reflection really doesn't affect the domain and range because anyways, for the domain it's left to right, and then for the range just bottom to top. So it's not really going to affect where you put the -infinity and +infinity. But then when you estimate the graph, it's going to flip the graph, okay? All right, so for the range, what is the horizontal asymptote, class? -4 is the k value. This is your k. So if you write y equals k, that means that's y equals -4 because the k value is -4. Okay? And so what is our range? That's going to be all real except -4. So -infinity to -4, union -4 to infinity. Okay, so if we estimate the graph, -1 is right here. So this is our VA, x equals -1. And then our horizontal is -4, so we shifted down 4. 1, 2, 3, 4 is right here. And then, so this is our HA, y equals -4. Okay, now since there's a reflection, again, from the left side, instead of starting at the bottom, the graph will be on top, okay? You can check on your Desmos, it's going to appear like this, okay? And then this. Okay, that's fine. I'm just going to draw the graph, estimate of the graph, make sure, just let me know if you're not able to copy the other parts.
It's fine. I know what I'm saying.
Oh. Okay. Okay, this one. -1 and then -4. 1, 2, 3. Okay, so that's the estimate of the graph. And then you'll do number 3 as your practice.
How would that work with it?
So we're just estimating the graph. We're not really doing it.
We're estimating the graph.
That'd be a stretch of 2.
Yeah, would that just be a stretch of 2?
It is stretched by still 4, but then your vertical asymptote will not be just 3 because of that 2 there. Yes, +3 halves. Remember, class, when you find the vertical asymptote, you're going to use the entire denominator. So it's not just x equals 3 for the vertical. You have to use the 2 there. Okay? So it's still stretched by 4, but there's no k value. Right? So that means the horizontal asymptote would be y equals 0.
Right, 3.
No, it's not going to be right 3.
It'd be right.
Right 3 halves, right? 1.5. Remember? Yeah. Because of the number, you have to solve for x, right? Because of the coefficient of x. Now I want you to do that, and then I'm just gonna write this here, and then I need a volunteer to write the answers. You solve for x. 2x minus 3, Christian. Set it to 0.
Oh, you're right.
Yeah. Hold on. Domain.
What do you think about now, Archie?
I hate her.
The stretch is just, remember, the stretch, you just stretch the y value, so the graph will really look like going to the y-axis.
No one likes
But when you estimate, you don't really need it.
Everybody hates her because she's annoying.
Yeah.
She just
But
barks still.
just estimate that it looks like going to the y. I mean, it should be, the vertical should have like 4 compared to the one above.
They told her she was going to stay the size she was when she was in public.
Right, yes.
She did.
You get your money back.
Okay, who can write the description here for number 3? Right.
I have no idea. I just know she's black. Well, my sister wanted a dog.
And then 4 there.
I don't know. I was like, that's a surprise. And I was in kindergarten. They asked me to hold her, and I hit her. 'Cause I didn't want her. This is like a normal one, right? It's just not close to the line. Yeah. And then so this one is a stretch by 4, like you're not really doing that afterwards.
Yeah. If the last one, you'd be like, oh, was that one quarterback that we had like 20 years ago? He was pretty decent. He never took an NFL snap in his life, but.
I think the arrows are supposed to be close, but like the curved part is like it's supposed to curve really early on.
No.
Yeah, it curves like away from the line.
My brain isn't doing math today. It's
We're
really
gonna
hard
do
to like put on my
3, 4, 5.
calculator to add names.
I do that.
I got it. Right?
No. Like,
I don't know that for Judith.
no, you're saying it's no.
I
I've never been to
don't
Wrigley.
know.
I know. Well, we didn't name her the.
Oh, 0.5.
I think
Well,
that
makes
was that
sense.
the pound. No, my dad only was
Number 3.
You didn't do the one
could have
on
named
the
it
back.
Negative 0.5.
She just left.
It's a baseball field, and it's like
Okay.
that's my dad's favorite baseball field. So he's like, no, we can't read it.
Yeah, here.
I wonder if your dad would still call me Barb.
I just
He
have
does.
X on the
Every time he refers to
Oh,
me,
no,
I
I
call
see
you
back to the
Barb.
back. I see the
Which is funny
He
because
Yeah.
only calls you Barb. I
I
haven't
just
talked
Barb,
to you.
okay.
I haven't heard him call
What'd
you
you do for
Leela
the
in like.
No, I have to write it down.
Oh, I haven't.
like years. How long have you been without the white wrap?
Since I was a
What's
kid.
funny is I completely forgot about that, and now I go to restaurants and I was like, I'm not
Okay, would you like to
So I say
explain
Barb.
it?
And I was
Hey,
telling
can
my
you
dad that. He's
explain
like, I
number
can.
5?
So
I can't remember. He's like, from soccer.
you basically set,
Pay attention.
sorry, I didn't really do the word for it, but you basically set the denominator to 0, so it's just 2x minus 3 equals 0, and then you subtract 3 from both sides, no, add 3 from both sides, and then you divide by 2, so you get 3 halves, and then the numerator is 4, so it's a stretch by 4, and then the domain is, it's not, the vertical asymptote is 3 halves, so it's, the domain is negative infinity, 3 halves, union, 3 halves infinity, because it can't touch 3 halves. And then the horizontal asymptote is 0 since you don't have a y value. So then the range would be negative infinity 0 union infinity 0 because it's not going to touch 0.
Okay. Very good. Let's give a round of applause. Thank you. Alright.
Your Lily's gonna run around and take the ball. So I just go from people and throw it away.
I hated my dad put me on defense. That was the worst.
I remember Kara was used to be bowling, she already got hit in the head, her glasses broke, and her mom said never again.
Really, I'm right.
Yeah, right. But
There
it's
was
the
one
same
year where
as
all three of us got 6.
Yeah, that was, we almost.
And then the next year.
3 halves is the same as 1.5. So if you wrote 1.5, that's correct.
Don't get rid of it.
And then I was also, that was also my basketball coach.
Okay, what about the next part? The next part is, given the description, we're going to write the function. Okay? I'm just giving you one example for that. So it's a lot of descriptions, a lot of transformations, but we're going to write that as a function. Let me know if you're done. Number 4.
So we were doing
My arms are always so.
Number 4, we're going to do that together. And number 5,
I was really embarrassed.
Next to X.
before. You're going to put it in front of it.
Oh, so it'd be like
1/2 times. Yeah.
that. Okay.
Okay. Right, so for number 4, we're given the description. If the function 1 over x, f of x equals 1 over x, is translated 5 units to the left, I'm just going to write, in this part class, I want you to write the parent function. We know the parent function is 1 over x, y equals 1 over x. And we're going to list down all the transformations before we write the new function, okay? All right, so 5 units to the left, that means one of the transformation is left 5. And then compressed by a factor of 1/2. So we say compressed by 1/2 or shrinked by 1/2. And then reflection across the x. We say flipped over x or reflection in x. And then we have 2 units up, or we can say up 2. And so we have all the 4 transformations, right? We're going to use this to write our new function. Okay, so write new function. So what will be our new function? You put 1/2, but because of the reflection, that's going to be -1. We can put the negative in your numerator for the 1, or you can put it beside the 1/2, right? So this is, I'm just going to write g of x. Given the function f of x, we're going to use g of x as our new function. G of x equals -1/2. Christian? -1/2 times
Can I go for Christian?
1 area will be next.
Wait, I go for Christian.
Area.
And then after Eric.
Yes. 1 over, how do you write left 5? X plus 5. And then plus 2 will be for the up 2, right? Okay. Any question with this new function? Okay, now for the last part, what if you're given a non-basic rational function and you're going to express that as a basic rational function where the numerator is constant? How do you write this? Okay, you're given a non-basic rational function because here the function f of x equals x plus 4 over x minus 3. The numerator is x plus 4, so it's not really constant. So this one is considered non-basic. Okay. Numerator is not constant. Okay. But if you're given this and you're asked to write the transformations of this function, because it's easier to have it in a basic rational function because it's easier to determine the features, right? The transformations. So we're going to express this as a basic rational function, and from there we can write all the transformations. Okay? I'm just going to write determine the transformation after we express this as a basic function. So what we can do is, you're just going to divide this using either synthetic division, or you can divide this using long division. So that once we divide it, we can express it as a basic rational function, right? Okay, let's just use this method, long division. Okay, so I'm going to do x plus 4 divided by x minus 3. Right? What is the quotient if we divide x plus 4 by x minus 3? That is just 1. Right? X, we divide the dividend, right? The first term of the dividend by the first term of the divisor. So x divided by x is 1. So 1 times this is just x minus 3. Okay? And then we subtract, right? So this one becomes a positive, and then proceed to addition. So that's going to be what? What's going to be the remainder? 7. Okay, so the quotient is 1, the remainder is 7, and the divisor is x minus 3. So remember, you can write this as 1 plus 7 over x minus 3. So the new function would be, I can write it in this form. We're going to start with this and then plus 1. So that's 7 over x minus 3 plus 1. Okay, so this is going to be our new function. Or the function, the equivalent function based on that. Right? So we converted the non-basic to a basic one. Now we have the numerator, which is constant. Right? Now, who can give me the transformations here? Okay, so we have right 3. What else? Right 3. What other transformation do we have? Up 1, yes, and then stretch by 7. And we're done.
So we have to put the 1 after. Because like
Yeah.
normally we would put the 1 before
yeah.
the remainder.
But since we're writing the rational function, the basic one, so plus k will be after the rational expression. Yes.